Hello and welcome to Aerospace Testing International's podcast. I'm Ben Sampson, editor of Aerospace Testing International. In a departure from our focus on new commercial aircraft, in this special episode I talked to Derek Hinton, chair of the ITC conference, the International Telemetry Conference. As well as chairing the conference, Derek works in the US defense sector and is an expert in his field. During this 30-minute interview, we discuss what attracts engineers into telemetry, the unique challenges they face, and some of the latest technology that's being tested, such as hypersonic weaponry. So, listen on, and I hope you enjoy the episode. Thanks for joining me today, Derek.
Thank you for having me. I really appreciate it.
Yeah, you're welcome. Okay. Can you just explain a little bit to me about the ITC and the conference and the way that the way you work with the sector, what the role of the ITC is?
So in general, the ITC is a major conference that's put on by the International Foundation for Telemetry. It's a nonprofit organization that looks at promoting the science of telemetry. We partner with universities, about 6 or so at the moment, where we basically endow professors and to help them build a curriculum to teach telemetry techniques, for lack of better words, and promote, as I say, the science of telemetry, and make sure that we are continuing the pipeline and growth of the professionals and in that technical domain. So that's the general emphasis of the nonprofit aspect of the ITC, the large conference that we have once a year, in order for us to generate revenue so that we can sponsor the universities to promote the science of telemetry.
Okay, and maybe we'll talk about the conference a little bit later, but I just wondered if we could just talk about the telemetry sector and ask you the question. I mean, what fundamentally drives improvements in the sector, and from the perspective of both the suppliers and the users?
So I'm going to talk to you from a perspective of someone who worked in the DoD in the test community for 30 years.
Yeah.
And so I'm not talking about the commercial side. So say Boeing and their development of commercial aircraft. I would be talking about Lockheed and Boeing from their development of DoD aircraft. Now, I certainly think the requirements that are generated from the DoD side certainly drive what happens in the commercial sector, but I just wanted to give you that caveat. So when I just say user requirement, I am really talking about the DoD community. And in a nutshell, what fundamentally drives the telemetry sector is the user requirements, the DoD requirements, and the suppliers responding to that. So if I may, I would want to kind of just give some examples of what those user requirements are and really what drives those requirements. So when you look at the development of weapon systems, that very broad category, let's just kind of talk about 2 aspects of it. As those systems have grown in complexity, they have taken on the characteristics of the most complex system that we know of, which is the human body. And so you get those characteristics of spontaneous behavior, feedback loops that are unpredictable, non-linear properties, and that requires just volumes and volumes of data that you need to collect in order to verify the performance of those systems. So when you look at the F-35, which is just a platform that sucks in a lot of data from off-board sensors. All that information has to be collected and telemetry to the ground, a lot of times in real time, such that you can evaluate the performance of that system and go on to the next data point. So requirements is what's driving it. One other thing that I wanted to look at is, so it's not only the complexity though, or talk about, I should say, the complexity of the systems under test, it's the environment that the test community has to generate in order for us to test these systems in the most realistic conditions as possible, again, with the ultimate goal to verify performance. So when you look at our near peers and the capabilities that they are developing these multi-layered standoff defenses across all the domains, air, land, space, cyber. And we have to create these environments, and then we have to monitor these environments. And all of that, again, is captured in telemetry back to the control facility such that you can maintain control and you can evaluate both the kinetic and non-kinetic aspects of the systems that are under test. So all of that is done in an environment. And one last point, our risk tolerance is almost zero. So we want to go off and do a test, and we obviously do not want to lose any life. We do not want to lose the system. And so that just drives the demand for data real time, exponentially. And so that's what drives our telemetry system. And let me know if I answered your question.
Yeah, you certainly did, Derek, very comprehensively. Thank you. And I mean, it seems to me it's fair to say that telemetry is more complex than it was, and it's always getting more complex because the data that you need to handle is becoming more complex. Is that fair to say?
That is very fair to say. And if we could just kind of capture it in a nutshell, our systems are smaller now. They require less power, but they still are required to transmit all those volumes of data that we were talking about. And all of this really has transpired in a very short period of time. Our systems 10 years ago were much different than they are now. If we can just kind of go back and think about our systems, it wasn't that long ago when our telemetry systems were large orange boxes to include the recorders with large orange wiring, analog, requiring lots of power that we would just strap into the aircraft.
Yeah.
We could record and store most of the data. We would record and store most of the data on board and only transmit those real-time safety of life, safety of flight information. We've now advanced, we advanced to digital PCM, FM modulation, but it was just serial stream. We can only serially stream the data, but we still recorded most of it on board. Now you kind of jump to, maybe 10 years ago, not that long ago, we transitioned to IP-based telemetry, which opened up two-way communication. This was a revolutionary change. Test engineers can now adjust parameters on the aircraft under test, let's say at 30,000 feet, real time. But we still recorded most of that data on the ground. And so now we are switching to, as I said, smaller systems, less power consumption. And this allows us to, we don't have to alter the system under test. nearly as much. And that allows for much more realistic testing. But now, one point, and we're going to talk about, it's a whole subject in itself.
Yeah.
When you go to the IP-based systems, you certainly open up some security risks. And that is something that we have to deal with and ensure that our telemetry systems build in security from the start as we are making these advancements.
So Derek, may I ask, with things changing so quickly within telemetry, I mean, that sounds like a massive challenge for an engineer and engineering organizations to deal with. I mean, how do you deal with that best? I mean, how do engineers stay abreast of what's happening and make sure that they're on the cutting edge that they need to be?
So I'm going to put a shameless plug in for the ITC conference, because that is one of the things that we do think we do well. Yeah. Is if you come to one of our conferences, the largest amount of participants are vendors in this area. And we have many technical sessions where the practitioners talk about the innovations and the techniques that they are using. We have a high participation rate from academia, where you get the scholarly innovations that are going on. So we can go from basic research to practical application in our conference, and our vendors are displaying the latest and greatest, hardware and software that has taken all that in over the last year, and the improvements that are made. So certainly one of our conference, we believe, is a good way to stay abreast. But also, by going IP-based, it has opened up us being able to go to commercial-based technologies.
Okay.
And that allows for rapid innovation, rapid insertion. It can help control costs, but I will emphasize, and most people stay abreast. Most techies are going to stay abreast of and cognizant of what's going on in the commercial sector, so the engineers can adapt and move fairly quickly. But I have to stress that certainly opens up security concerns.
Okay. All right. So, I mean, it sounds like as the sector continues to move forward, these kind of cybersecurity concerns, they're high up on your list of priorities?
Very much so. We for the 2020 conference that we had to cancel, one of the featured speakers was going to be a technologist from Lockheed Martin, where I'd asked him to just go do an open source search and analysis of 5G vulnerabilities. It is no doubt that we are going to adapt some aspects of 5G technology, maybe a lot of 5G technologies, in the way they do the small cells and the frequency bands that they transmit and so forth. And we were going to do this open source, and he was going to do this open source assessment of the vulnerabilities that are just floating around on the internet, again, for lack of better words, and just to give the practitioners in the room awareness of things that they need to think about as we modernize our telemetry system, such that we build in security from the start. Now, one of the things that we are planning to do, since we had to skip this year, and we've been thinking about it, is going to actually secure sessions where we will probably take that open source, which would be non-classified, but also do some classified searches of known vulnerabilities and do a session on those as well.
Hmm.
So we can help awareness and look at mitigation techniques to make our telemetry systems as secure as possible.
What kind of techniques, I mean, do you employ to make sure your telemetry is secure?
So right now, the biggest thing that we use is encryption,
Right.
and that certainly is a level of security. But the things that we have to make our practitioners aware of, you think by having an encrypted system that your communications is secure.
Yeah.
That's a natural assumption.
Mm.
If I put out a rogue signal on the frequencies that you are transmitting, and your receiver expects that frequency, that signal to come back, now that you're doing two-way communication, you ingest it into your telemetry system. I now have access to your system. And I may only transmit one bit, at a time, to a point where I have, over time, put enough bits of information into your system to put some malicious code there,
Yeah.
executable code. So we need to put protocols in place that do you check to see if one bit of additional information has entered your system. You got an encrypted system, so that probably is not something you're thinking about.
Mm.
So it's just to make um, our practitioners aware of what the adversary is doing,
Hmm.
and such that we can then come up with the right security protocols. But it really stems from awareness, because once you are aware of what the adversaries are doing, there are mitigation techniques out there to solve those problems.
Right. Okay. And we don't want to scare everyone about the threat of cybersecurity. I mean, there's some great opportunities and some great advancements happening in the sector as well, isn't there? And you mentioned 5G earlier on. Would you say that's the biggest deal coming up for you guys, or is there other stuff happening you'd like to highlight?
I would say 5G is certainly the biggest deal for a couple of reasons.
Mm.
There are a couple of other things, though, that I want to highlight or would highlight,
Okay.
but 5G is a big deal because, one, we can leverage that technology and probably reduce the overall cost of putting out a much more robust telemetry system and capability out on our range complexes. And I think most people understand that. But it's a risk also because there are known security vulnerabilities, and we don't, like I say, we don't need to scare everybody. We've talked about that.
Mm.
But the other part is the commercial sector has this insatiable desire for more spectrum,
Hmm.
and that is going to um, at least cause a lot of innovation in spectral agility, the ability to share spectrum with the commercial sector, and that's going to drive innovation in itself. And so there's a lot of possibility and a lot of great opportunity to increase capability by leveraging 5G technology. But that insatiable appetite for more spectrum is going to force the DoD test community to be more innovative. Now, one of the things, though, that I do want to highlight is significant improvement has been made in the modern digital modulation techniques that our telemetry systems are using. and we are really pushing state of the art in that area. And the bottom line, by going to these more efficient modulation techniques, we are able to squeeze, more data and less spectrum, more bits per hertz. That's what it all amounts to. And there has been significant improvement in that area. And I know the DoD test community is going to continue to invest in that area. So IP-based technology
Mhm.
certainly is worth its weight in gold. Again, for lack of better words, but that push toward those more improved spectral efficient modulation technique is what's going to allow us to accommodate those vast volumes of data that those complex systems and those environments and those long distances where we collecting data for a long period of time over those vast distances. Now, I would throw in one other thing, and I didn't mention this. Hypersonic technology is going to drive the need for what I'm going to call burst technology, because you're going to a burst capability, because you're going to launch these hypersonic weapons, and you won't test them all the time over their full envelope or their full flight envelope. So you're going to have very short duration tests where you're going to need to just get a whole lot of information over a very small period of time. And you're going to need a highly efficient telemetry system to transmit all that information in that short window of time. And that's going to drive innovation in our telemetry systems.
Wow. There's some programs going through at the moment, isn't there, that are for hypersonic air vehicles, and that's where you guys are at the moment, getting the data off of those vehicles. And isn't that coming up this year? I think there's one happening.
We being the DoD have had some very successful flight tests in the last year. So the innovation in hypersonic technology is really moving rapidly. For many years, the DoD has been pursuing hypersonic technology, and and for lack of better words, they didn't make the investment in ground test propulsion test capabilities, and they have done that, and they are now being able to better optimize their propulsion capability, which is now allowing them to have better open air flight testing. So that technology is moving rapidly, and it's one of the highest technology pushes priority-wise in the department. And so the rapid innovation is going to drive, again, the need for innovation in our telemetry systems.
Okay. I'm just wondering, Derek, I speak to a lot of engineers, and one of the common things I get to hear is that there's always pressure on costs and time. Is that the same in telemetry as well? Would you say there are factors that shape the design and deployment of telemetry systems, that pressure to reduce costs and do things faster all the time?
I would absolutely. In a nutshell, that is there. Form, fit, and function is a critical driver when you have limited test assets and can only do so many open air flights because of the cost. You can't afford to be intrusive on that system under test. And I'll just use the example of a typical missile, but only as an example. Normally, when you go in and do missile testing and you have to fully instrument it and telemetry, all the information, say you want to verify the flight controls and the guidance system and whether the fuse is working, you end up having to take that warhead out. you have to take the warhead out of the missile to put your telemetry package in. And now you can then go off and do a full, end-to-end flight test of that missile, but you haven't taken it all the way to terminal to get the terminal effect. And let's just say you only had 10 of those missiles. And at some point, you're going to have to go full end-to-end all the way to terminal effect. Mm-hmm. So what you need to do is figure out how you can get your telemetry system on that missile as non-intrusive as possible so you can exercise all of its components and subcomponents to include the warhead. Mm. And now you just kind of extrapolate that, say, to a hypersonic missile where you aren't going to, you may not have 10 articles that you're going to do open air testing on. So how are you going to instrument it? How are you going to get your package on there, drawing, taking up the least amount of space, drawing the least amount of power, but giving maximum output as far as data throughput that you are streaming. So form-fitting function is a major driver, mm-hmm. and it's a major driver because you have such limited test assets in a lot of the cases. Yeah. And you have to be able to get the most data, in the least amount of trials. Mm. So it's a major driver.
Okay, but let's talk about the conference. Come back down to earth and talk about the conference just quickly. You mentioned earlier on, that it's a great way of keeping up with what's going on in the community and keeping current with the technology that's available. I mean, is it a big setback not having the conference this year? And how can people mitigate that not having the conference?
Well, I'm again, you're certainly talking to someone that's biased. I've been attending the ITC conference for many, many years, and I know it's a great venue for those technical interchanges, staying current on what's state of the art in this domain area. We are searching and working on trying to come up with ways to keep that information out there. To answer your question directly, I believe it is a setback because I think we kind of talked about the field is changing rapidly. And there's been, a lot of innovation that has occurred over the last year or couple of years, and for the practitioners to stay current, they need to have that engagement. I certainly believe at least once a year with the vendor, with the suppliers, and people who are setting the requirements. So the people who are kind of making all of this work out on our ranges need to have that interchange to stay current. And I will say your willingness to allow us to talk about the conference is a way for us to help mitigate it somewhat. We're looking at other options where trying to maybe have a couple of virtual sessions where we can at least highlight what's going to occur in 2021 and talk about the specifics of some of the papers that are going to be presented, because that way the practitioners can at least see where the technology trends are headed. By where the intellectual capital, the people that are going to be writing these papers, where they are spending their time. But it's real hard in the virtual sphere to mitigate not having the actual conference, for lack of better words.
Yeah, it is, and Well, I mean, hopefully things will be back to normal next year, and you've got plans to hold the conference next year, obviously.
Yes, we do. We're going to do it in Las Vegas in the October time frame.
Mm.
And like I said, we're going to try to make it a little bit more robust.
Mm.
Uh, we're certainly looking at adding that classified session or sessions to give more in-depth explanation and some of the more in-depth examination in some of the areas, and security being one of those. So absolutely, planning to hold the conference in 2021. We will do a few virtual sessions, like I said, to at least try to show where the intellectual capital is being spent, so that the practitioners can look at the technology trends, but really just to prep and get ready for 2021.
Okay, great. And I just to finish up, Derek.
Good points there from Derek about a niche, but I think you'll find a really interesting area that doesn't get a lot of mainstream coverage normally. So I hope you enjoyed it and found it interesting. Remember, you can subscribe to the podcast at aerospace-testing-international.com/podcasts or on the Apple or Spotify podcast platforms. Our next episode will be about a electric regional airliner being developed in Sweden. So expect that next month. So in the meantime, goodbye and stay safe. Thanks.